Hope everyone's having a good day. If anyone isn't, I'll try and make it better. So, as he said, I'm Deryck. I work for BOA Hydraulics, and what I want to speak about is understanding hydraulic hose repair and maintenance for better business outcomes. So, as a person who's passionate about innovation, and I'm passionate about getting better outcomes, I want to set the scene for this presentation by saying not all hoses are created equal. Now that might sound cliche, it might sound like I've stolen it directly from Sales 101, not quite. I'm not going to try to sell you a specific brand here. What I'm wanting to talk about is, if there's one thing I've learned over the years in the hydraulics game, the one thing that's really important to understand is what's good, better and best when it comes to hydraulic hose and fittings, and particularly hose. So you know, you might say a hose is a hose, but there's a lot of marketing noise out there, and it's important to get through the marketing noise down to what is a good hose and where the value is. So a hose essentially is quite simple. It's got an inner lining, it's got some form of reinforcement, and it's got an outer layer that might be a smooth or wrapped construction. Typically the inner tube is pretty standard, as long as it's the right material and a decent quality. But it should last. The reinforcement, typically in the hose we deal with, is 1 to 6 high tensile steel, either braided or spiral wires, and it's actually plays a big part in the quality of the hose. And what it comes down to is the angle of the wires versus along the length of the inner tube, because that's what gives you your strength and your flexibility. And just a small adjustment in angle can make a big difference. And finally, there's the outer cover. The outer cover is generally made of rubber and carbon and whatever other additives particular manufacturers want to put in. To make a tougher cover, manufacturers generally add carbon, but you've got to be careful, because just because it's got more carbon in and it's more resistant to abrasion, it does affect flexibility, and it will affect also its resistance to impact, because it's a harder compound. So just a little bit of around how hose is tested. Obviously there's a couple of different methods that we've got up there. We've got the square wave test and the peak wave test. Now the square wave test is where hose is tested by taking it up to about 130% of operating pressure. It's held there for a while, dropped down, and that's repeated at a set oil temperature for a set number of impulses. The peak wave test takes it up to 150% of working pressure, drops it back down to working pressure and holds it there for a while and down, and then repeat it at the set amount of impulses. Now the interesting thing is the square wave test is what most international standards require, most of the standards you'd see, and they require it at 400 to 500,000 impulses, but that doesn't really accurately simulate the conditions hose actually face, because realistically in operation it's more likely to peak, come back down, run at the system pressure, and then peak again when there's another action. So Hitachi and Komatsu, they said they didn't think the square wave test was what they wanted for their machinery. Original hose on their machinery must meet the peak wave test and 1.2 million impulses, so quite a lot higher than international standards. Now fittings, if you've got a good hose, you want to put a good fitting on it. There's a lot of literature out there that says you must have a matched hose and fitting. Absolutely true. It's a safety thing. But it doesn't mean that the hose and fitting have to be the same brand. So long as they're certified, that you've got a certified crimp spec for that fitting on that hose, and it's certified to have passed for a pressure test, you're good to go. So I'll just flick through 4 key areas I want to cover when we're talking about better business outcomes. We're talking about preventative maintenance, contamination, good practices, and innovation and disruption, which is the exciting bit. So preventative maintenance, all about thinking ahead and seeing the cost and time benefits of thinking ahead. As with all things proactive and preventative, we tend to become too busy and put them aside. However, if it's not done preventatively, it's only going to create more work in the future. If you don't schedule maintenance for your machine, it will schedule it for you. Preventative maintenance in terms of hose and fittings is a win-win solution. So whether you're working on your own machines or third parties' machines, it's great to do preventative maintenance because you're less likely to have hoses blow in service. When a hose blows in service, it causes costly downtime and increases the risk of injury. If you replace a hose preventatively, you're going to have less oil contamination from spilt oil and environmental impact. So speaking in the context of having hose manufacturing abilities in-house, traditionally not the way it's been done, but it's actually quite possible. You don't need to have qualified as a hose guru at an institute to say you can make hoses. If you have the right tools, the right training, you're 80% of the way there. And a little saying of mine, if in doubt, swap it out. But don't do it like that. And so what do we want to look for in worn hoses? We want to look for things like impact marks and abrasion. If it's worn the outer cover down to the wires, you're going to get oxidisation of the wires, you're going to lose structural integrity. You want to replace that hose. If there's any oil seepage or bubbling of the outer cover could indicate there's oil working its way through, so impending failure. Any heat or environmental aging where the hose becomes rigid, and any kinks or pinches, which especially if you're dealing with excavators, you've probably seen it already. So contamination, largest cause of component failure, accounting for over 90% of hydraulic component failures. So even tiny particles of contamination in oil, when passing through fine tolerances of valves, etc., at pressure can cause damage, especially over time. And untreated, this can actually lead to invisible declines in performance by up to 20%. So that's like losing a day's productivity every week. So it's a big deal. So how do we combat this? Firstly, use the proper gear. I know a lot of people cut hydraulic hose with grinders. It's not ideal to use a grinder or a cutting disc. You're immediately creating a lot of friction and heat and a lot more contamination, and it will enter the hose. The heat will also make it stick inside. If you use a proper cutting saw, you can the pins on the saw will open the hose up, reduce the friction, and the blade's designed to cause less contamination and heat. Next thing is a wadding gun. It's recommended to fire a projectile down the hose in each direction after cutting it, and then again after crimping the ends on. So when you cut the hose, obviously we've seen the contamination that gets into it, and when you crimp the ends you get the metal flash from the zinc coating can enter the hose as well. So it's a safeguard to do it after cutting and again after crimping. So good practices. Now, it's a fairly generic subject. Everyone's got good practice in some way, but to me good practice means going above and beyond minimum standards to achieve your desired outcome. You want to do better. Good practice comes down to being proactive, following procedures and implementing continuous improvement. So our attitude towards good practices often comes down to the culture that's being promoted. Think about a set of cogs, like I've got up there. If the smallest one was to stop working, no matter how hard the other two try work, they're not going to be able to do their job. So it's important that we make up and do our part. On good practices, we need to know, in the terms of hydraulic hose and fittings, what the hoses are for. The age-old method is STEMPed, standing for size, temperature, application, media, pressure, ends and delivery. So if we just speak through each of those. So size refers typically to the ideal inside diameter of the hose. It's the first thing we'd think about when it comes to size. That is the critical dimension to look after the physics, such as the flow rate and getting the right amount of fluid to the right place at the right time. In some applications where you've got limited space or you're running a hose over a guiding pulley, you want to take into account the outside diameter and the bend radius of the hose. And a dimension that often catches people out when they're talking about a hose assembly is, are you talking hose length or overall length? If you're manufacturing hoses for someone else, always make sure you know what they're talking, otherwise it'll get there and stop 20 mil short of the other end. Coming to temperature, this is not only oil temperature, it's environmental temperature as well. So you want to make sure you're within the operating range of the hose you're using. In New Zealand, it's not quite the same as in the far northern hemisphere where they have to deal with extreme cold. So for us, temperature would relate to hoses working in freezer rooms, near furnaces, etc. You want to, and engine bays is another one. You want to make sure you're operating within the specified range of the hose. Now, application. Understanding where the hose is going is important. Working conditions can vary greatly. So, largely we'd know where a hose we're making is going, and some good questions to start with are, will this hose be subjected to harsh external conditions? So this can be temperatures we've discussed, abrasion, impacts, dragging along the ground in some situations. And will the hose be in tough operating conditions internally, so high impulse rates, pressure spikes, severe vibration can all affect hose life. Then there's the standard good practices, such as allowing for motion absorption, avoiding torsional twist when installing a hose. You want pressure absorption. Pressure will make the hose pulse a bit, so you don't want it too tight. And using the correct fittings and adapters to route the hose so it's not getting bent on more than one plane. But if there's anything I can't stress enough when making a hose, it comes down to 4 points really. One is make sure the fitting is pushed right on. Around 40% of hoses I see come back to us from customers that have failed are caused by the fitting not being pushed right on. First thing I check for every time. Collar alignment. So if you're using a two-piece fitting where you've got the hose tail and the ferrule as separate pieces, always make sure the collar and the groove align when you crimp them together. If not, you put it under pressure, that fitting will push out fairly fast. Now on most brands of fittings you have to crimp the whole ferrule. There is some out there that you do a bubble crimp on, but if you're unsure, check with your supplier. Make sure you're crimping correctly. And always check that you've crimped to the right crimp spec. Sometimes it can look good, put it under pressure, and you've all of a sudden got a blown hose and a lot of oil on the ground. So we come to media. You need to know what's going through the hose. For example, is it standard hydraulic oil, is it fuel or diesel? It will require a different hose. The inner liner will be made of a different product. Pressure. Pressure can be stated in a number of different units. Make sure you understand what you're dealing with, what it means. And it's also important to understand whether you're dealing with static or dynamic pressure. So by that I mean dynamic pressure means the operating pressure can fluctuate, potentially causing shocks and spikes and vibrations. So the hose should be rated to handle the system working pressure plus the impulse pressure. It's one that's often missed. Come to ends, terminations, fittings, however you want to refer to them, they're the same thing. And we want to make sure we've got the correct thread, connection type, angle, material, and orientation on the hose. So if you've got two angled fittings on the end of a hose, you want to make sure you've got them lined up right, that it's actually going to go on when you get to the application. Easy one to forget, you whip the hose off the machine and don't mark it. And you come to make it and you suddenly find you don't know how to put the ends so they're situated right. So there's several different thread combinations and types in the market, and you combine that with the sizes, the combinations are pretty much endless. So the easiest way to identify the correct connection is first to measure the thread or connection with the verniers, then visually match the seat type against a chart or diagram, and that'll bring you down to the right fitting generally. So we're on to delivery. Delivery means what are the specific needs of the application. Are there any special requirements such as marking the ends or labelling the assembly so the next person knows where it goes? Have the ends been capped to avoid contamination while it's in transit? Now, innovation. This is the bit I love. I like to go back to the basics of innovation. What is innovation? Well, the dictionary definition is something new or different introduced. Really pretty simple. So for innovation to make a difference, we need to be prepared for change and disruption. We need to truly accept change and disruption. We need to shift our paradigms. So what this means is we need to shift the way we see things. As an industry, the hydraulic space is moving forward with the times, I believe. So it's important not to get stuck in the status quo. Machines are getting smarter and machines are getting more connected. As I've gone over, with quality hose and fittings, preventative maintenance, contamination control and general good practices, what the industry needs to innovate is the tools to take back control of hydraulic repairs. So you've got everything where you need it. You need to answer the who. That means who's going to be responsible for doing the hydraulic repairs. You need to answer the what. That means what is the hose recipe? Do you know it in advance, or do you only know it when you've pulled a hose off and you're matching it up? Answer the how. There are innovative options available, and I'm not supposed to sell, but there's a good innovative option in the foyer, makes you have a look at it. There is so much more the industry can do. We need tools to implement methods that allow us to understand, analyse and predict the behaviour of our assets. And that way we can get better cost and time efficiencies. We need new tech and better safety tools, allowing businesses to take back control and be more accountable. This will enable a much better understanding of assets and drive better business outcomes. A project I'm working on is a tech project. We call it the BOA Hub. It's a web and mobile application to address some of the key areas that I've just spoken over, of identifying hose recipes, etc. You can come see us about that afterwards. So with that, I believe with adherence to best practice and taking back control, we can be assured of better business outcomes both immediately and into the future. Thank you.